Okay, so the first application of an electric field is what they call xerography, which is a fancy word for photocopying. Here's how it works. Yeah, it's the name Xerox, the company. Xerox comes from the process, exactly. Okay? Figure 1 illustrates an office copy. Now, keep in mind, this comes out of a textbook that's entitled probably Modern Physics. It was probably written back in the late 80s. So, slightly different technology, but the basic principles are the same. The copying process is called xerography, from the Greek word xeros and graphos, which means dry writing. The heart of the machine is the xerographic drum, an aluminum cylinder coated with a layer of selenium. Aluminum is an excellent electrical conductor. So what does that mean? Conducts electricity, right? Electricity can pass through it. Selenium, on the other hand, is what's called a photoconductor. What do you think photoconductor means? No. Come on. Highlighter. Highlighter. Photoconductor. It's an insulator in the dark, but becomes a conductor when exposed to light. Consequently, if a positive charge is deposited on the selenium surface, the charge will remain there provided that the selenium is kept in the dark. If the drum is exposed to light, however, electrons from the aluminum pass through the conducting selenium and neutralize the negative or the positive charge. The photoconductor property of selenium lies at the core of the xerographic process. So here's how it works. Figure 2 illustrates the 5 steps of the process. First, an electrode called a corotron gives the entire selenium surface a positive charge in the dark. So here's the corotron right here. And here's the selenium-coated drum, this big sort of drum here. And the corotron gives it a charge. And it's in the dark, so the charge stays there. Colby, are you following along here? Because this is one of those sort of follow-along kind of things. You're not going to be able to sort of figure it out at the end. Okay? It's not going to work. Secondly, a series of lenses and mirrors focuses an image of a document onto the revolving drum. So in the case here at the bottom, right? So actually this is probably better to follow along here at the bottom, right? So we've got the selenium-coated drum here. It's got a positive charge. What's the document say that we're photocopying? It's a big number 3. Maybe kindergarten teachers putting something up on the wall. It's a big, giant number 3, okay? So that number 3 is focused on the drum. The dark and light areas of the document produce corresponding areas on the drum. The dark areas retain their positive charge, but the light areas become conducting and lose their positive charge, ending up neutralized. Thus, a positive charged image of the document remains on the selenium surface. So in other words, you get a big number. Here everything is positive. Here we get a big number 3, but you can't see it. It's in positive charges. So there's a big number 3 in positive charges on the drum. Does that make sense? Okay, so there's like a region, there's like a space that looks like in the big number 3. You can't see it, it's just made up of positive charges. Okay, in the third step, a special dry black powder called the toner comes in a big plastic jug. Secretary plugs it in there and kind of feeds the photocopier, fill it with toner, is given a negative charge and then spread onto the drum, where it adheres or it sticks selectively to the positively charged area. So they dump the toner on, right? And where does it stick? Where the positive charges were. Where it hits a neutral charge, it just slides right off. Okay? And so you end up with, on the drum, what do you end up with? Now not a positive charge 3, but an actual number 3 that's made up of toner. Okay? Made up of toner. The fourth step involves transferring the toner onto a blank piece of paper. However, the attraction of the positive charge image holds the toner to the drum. To transfer the toner, the paper is given a greater positive charge than that of the image with the aid of another corotron. So the paper is actually charged positively, actually negatively, right? A greater negative charge. So all that ink comes off onto the paper, and then there's a last step. Lastly, the paper and the adhering toner pass through heated pressure rollers. As a result of the heat, the toner melts into the fibers of the paper and produces the finished copy, which is why when you get a fresh thing right out of the photocopier, it feels warm because it melted the ink right into the paper. Okay? That's pretty cool process. As a kid, I remember my dad was a teacher as well. As a kid, I remember going to school on the weekends or whatever, helping them out with stuff. And he actually had they had a thing called a mimeograph. You may see them in Grandma's house, the photocopies. Mr. Stozek, we'll ask him. Mr. Stozek, did you have to photocopy with a mimeograph machine with that pink fluid? Did you ever have to do that as a young teacher?
We had Spirit Masters,
Yeah.
blue,
Yeah.
remember those?
Yeah, and you had to crank it, right?
We had, when I was going to the country school, we had the Gestetner, and we had the Gestetner also when my first year for 2
And that was the one you cranked, right?
And it had a like a jelly.
Yeah. Wasn't the photocopies kind of like a pink kind of, I remember them, no?
Like a shirt.
Yeah, similar. Yeah, what favorite is for that? I have none like that, I just have the...
Down to 3. That's where they are.
Really? Okay, so that is xerography. Flip the page over. We'll move forward in the future a little bit. And laser printers. Who has a laser printer at home? Anyone? Here's the tip I've learned recently. I used to have, how many people have an inkjet printer at home? Nobody prints anymore, apparently.
Costs
You
too
know what that
much.
printer is? The inkjet printer is the kind that comes with the little cartridges that are always dry and never work. Okay? You have that? Yeah, I finally got smart and bought myself a laser printer at home. The cartridges cost a little bit more, but they never dry out, and so you actually save money. So if you are buying a printer for university, don't buy inkjet. You'll save maybe 20 or 30 bucks initially, but you'll lose money in the long run because the ink will never work.
And you're just doing black and liquid laser, and one I have this is black.
Yep.
I don't color. You go to Walmart.
Exactly. Yeah. Don't bother buying an inkjet printer. Here's how a laser printer works. Now our photocopiers here at the school are a combination photocopier laser printer. Like I can send copies from my computer down there. So the process of xerography is a little bit different. It's more actually like printing when you actually photocopy, because it actually takes a picture and then it scans it and then actually prints it. Is what it's doing. Anyways. A laser printer is used with computers to provide high-quality copies of text and graphics. The laser printer is very similar in operation to the xerographic machine, except the information to be reproduced is not on paper. Instead, the information originates in the computer's memory and is transferred to the printer through an electrical cable. Laser light is used to copy the information onto the selenium aluminum drum. A laser beam, focused to a fine point, is scanned rapidly from side to side across the rotating drum, as figure 3 indicates. While the light remains on, the positive charge in the drum is neutralized. As the laser beam moves, the computer turns the beam off at the right moments during each scan to produce the desired positive charge image, which is the letter A in the picture. So down here on the left, I got to go to the next page on mine. But instead of photocopying a big giant 3, we're now photocopying a big giant A. Okay? So instead of the photocopier using lenses and mirrors to put that image on the screen or on the drum, okay, the Coratron puts that positive charge on the drum, and then the laser goes back and forth like this, turning on and off at the right points so that you get the image in positive charge on the drum of your document. In this case, the big giant A. Okay, so it's very, very similar to the previous process. And then after that, it is literally pretty much the same thing. Okay? Figure 4 shows the general mechanism that turns the laser beam off and on as it scans across the xerographic drum. The light from the laser is sent through a device called a modulator. The modulator also receives the information to be printed from the computer and accordingly either allows the light to pass or blocks it. Thus, the laser output beam from the modulator is turned off and on at rates often exceeding 1 million times per second, flashing that light on and off. The output beam is then directed by a series of mirrors and lenses to a rotating polygonal mirror that causes the reflected beam to sweep from side to side. When the beam reflected from the rotating mirror is directed onto the xerographic drum, the beam scans across the drum, produces the positive image charge, and then what happens? Exactly the same thing as what happened with the photocopier, okay, which is it puts the toner on. Where does the toner stick? To where the positive charge is. Adds a greater negative charge to the paper, toner jumps out of the paper, and then it melts into the paper on the way out, which is why when they come out of the printer, they're also warm, okay? Last one is the inkjet. Okay, now this is the one that most people have at home. If they still have printers, they're maybe not quite as popular as they once were. An inkjet printer is another type of printer that uses electric charges in its operation. While shuttling back and forth across the paper, the inkjet printhead ejects a thin stream of ink. Figure 5 illustrates the elements of one type of printhead. The ink is forced out of a small nozzle, breaks up into extremely small droplets whose diameters are less than 4/1000th of an inch. Very, very tiny. Typically about 150,000 droplets leave the nozzle each second, travel with a speed of approximately 40 miles an hour toward the paper. During their flight, the droplets pass through two electrical components, a charging electrode and the deflection plate, which is a parallel plate capacitor. And that's actually the part that interests me, because this, the parallel plate capacitor, creates an electric field, just like the ones we've been talking about. Okay? So here's how it works down here. When the printhead moves over regions of paper that are not to be inked, the charging electrode is left on and gives the ink droplets a net charge. The deflection plates divert the charged droplets into a gutter and thus prevent them from reaching the paper. So here's the picture down here that probably explains it better. Okay? So here's the paper over here where you want to print. Okay? Here's the nozzle, so the ink is coming out here. The ink is given a charge as it goes through there. Okay? And the deflection plates, okay, so if these are positively charged, the deflection plates down here, this might be negative, and this would be positive. Right? So if they have a charge and they get into this electric field, where does the ink go? It gets pushed down into a gutter. I believe sometimes it is recycled. Okay? If it's not charged, right? Whenever ink is to be placed on the paper, the charging control responding to the computer turns off the charging electrode. So if they're not charged, what happens? Is there still an electric field? There is. Are the ink drops charged? They are not, and so they go where? They go through right onto the paper. And then this nozzle is going back and forth. You know those printers that go back and forth like this? Okay, that's what an inkjet is, okay? So it's shooting out ink, and it's either being charged or not charged, and depending on whether it's charged or not, it's either deflected into a gutter with an electric field. If this is positive and that's negative, which direction is going to be electric field? Right? Away from positive, right? So there's an electric field used inside your inkjet printer. Inkjet printers are popular because they can produce color copies. Full color printheads use at least 3 nozzles for different colors, usually cyan or blue, magenta, and yellow. Often they also use a 4th nozzle for black ink. By adjusting the amount of ink that each nozzle produces, the printhead can deposit any color on the paper. So back to kindergarten, mixing colors, you can get color copies, right? Which is why inkjet printers are popular. They're also reasonably expensive. You can get inexpensive. You can get one for less than $100. But the ink tends to dry out because it's liquid. What kind of ink do they use on laser printers and photocopiers? They use that dry writing. They use dry toner, and it doesn't dry out, which is why they're cheap. Okay, so I will ask you to explain one of those 3 on the test. Randomly selected one of those 3 steps. Maybe I should have said that at the start of this little thing, eh? Maybe I would have had more attention. Oh well, good thing I recorded it. You can go back and listen.